Okay, well, welcome to my session, Introduction to Azure SQL Database Serverless. Hope you're all enjoying New Styles of Data so far. Big thanks to Ben and William for organizing this event and also for giving me the opportunity to speak here today. So a little bit about me. My name's Shaun Atkinson. I've been working with SQL Server for about 10 years. I helped to co-organise the Manchester Data Platform user group in the UK, and I'm also co-organised a few SQL Saturdays in Manchester as well over the last few years. And I've also been a volunteer at SQL Bits for the last 5 or 6 years as well. The most important piece of information on this slide is my Twitter handle @WheelieDBA. Please follow me on Twitter. And if you think of any questions or comments after this session, then just drop me a message on Twitter and I'll get back to you. So before we start talking about serverless, I'm just going to take a step back and go through very briefly the SQL Server options that we have in Azure. So the first option that became available was the infrastructure as a service offering, the virtual machine. You span it up in Azure and you managed it, the security, the patching, the upgrades in the same way you would as if it was in your own data center on premises. Then a little bit later, Microsoft released Azure SQL DB. So this was for single databases and it was a platform as a service offering. And the difference was that Microsoft managed all the upgrades, the patching and the security, so you didn't have to. The downside of that was, though, that Azure SQL DB didn't cover the full surface area of SQL Server. So you didn't have SQL Server agents and you couldn't do cross-database queries out of the box, but there were workarounds for those. So because the full SQL Server service area wasn't covered, Microsoft then later released Azure SQL Managed Instance, which is the platform as a service offering and it's full SQL Server functionality in the cloud, and Microsoft look after all the security, patching and upgrades for you. But my session today is going to focus in the Azure SQL DB space. So where did all of that start? Well, it started with DTU-based purchase models, the basic, standard, and premium service tiers. And in these service tiers, you got anywhere between 5,000 and 4,000 DTUs, depending on which tier you put it on. So you had the basic tier, which was designed for your low compute dev workloads. You had the standard tier, which was designed for your typical production workloads. And you had that premium tier if you needed the extra compute power to go all the way up to 4,000 DTUs. And with the DTU-based models, you would build for the DTUs that you provisioned and the storage that your database needed. So, for example, if you had a database on the basic tier, you got 5 DTUs, regardless of whether you use those full 5 DTUs or not. Maybe most of the time your database was only using 3 DTUs, but you still got billed for 5 DTUs. And the other thing about the DTU-based purchase models was nobody was quite sure how to measure a DTU. There was lots of people wrote blog posts about it, but nobody could get a definitive answer. It actually turns out that a DTU was an OLTP benchmark that Microsoft created, but never released. So to solve some of that mystery, they then introduced the general purpose service tier, or what we know today as Azure SQL Database Provisioned. So this was a vCore-based purchase model, and Microsoft fully documented how much CPU and memory that you got per vCore. Again, it was designed for regular usage databases that had high compute utilization or multiple databases with elastic pools. And elastic pools, essentially, you could assign a certain amount of vCores and they would be shared between a group of databases. And it was an equivalent to having a SQL Server instance, but up in Azure rather than in your on-premises data center. So with provisioned, when you scale up the resources, you actually get some downtime with that while that scaling up operation is taking place. The other thing about the scaling in provisioned is that it actually needs some manual intervention. It needs somebody to go into the Azure portal and scale the number of vCores up and down, or it needs somebody to run a script in the background, even if it's a scheduled job, to scale those resources up and down. Either way, the emphasis is always on you as the developer or the DBA to decide when the resources need scripting up and down. Provisioned is billed per hour, and like the DTU-based purchase models that I've just talked about, you are billed for the vCores and the database storage that you provision, regardless of whether or not that gets used. So because you get billed for what you provision rather than what you use, it kind of led to two provisioning approaches with Azure SQL Database. People would either overly provision or minimally provision. So people would over provision. So say you had a workload which on average used 4 vCores most of the time, but occasionally there were spikes in that workload which took it up to 8 vCores. So somebody would provision 8 vCores to allow for those spikes in workload. So the good thing about that was you could deal with the spikes in the workload. The bad thing about that was you were getting charged for 8 vCores, even though most of the time you were only using 4. So this led then to some people taking the opposite approach, which was to minimally provision. So sticking with the example I've just been talking about, if the workload's using 4 vCores most of the time, then somebody would provision 4 vCores because that's what it uses most of the time. So the good thing about that is it costs you less, but the bad thing about that is there's no scope in your provisioning for spikes. So you'd have to deal with that either manually by scaling the vCores up in the Azure portal or by some kind of script in the background in, say, Azure CLI or PowerShell. Either way, the onus is on you as the developer or the DBA to decide when those vCores need scaling up or down. So to help overcome some of these problems, Microsoft has now introduced Azure SQL Database Serverless. So like Azure SQL Database Provisioned, this is a vCore-based purchase model. It optimizes price performance for workloads. What that essentially means is it tries to give you the best performance for the minimum possible price. Or put another way, you pay for what you use rather than what you provision. So it's designed to try and overcome that problem of either minimally provisioning or over provisioning. And with that come a number of features. First of those features is automatic scaling. So what you do with serverless is you define a minimum number of vCores and a maximum number of vCores. And then in the background, serverless will scale up the number of vCores up and down as they are needed by your workload. You don't have to do anything. No scripting is needed, no manual intervention is needed. You just need to set that minimum and maximum figure, and then serverless will do the rest. The other thing about serverless is there is no downtime involved when you scale up the number of vCores like there is in provisioned. There is one very rare scenario where that might happen, and I'll talk about that a little bit later on when I go into auto-scaling in a bit more detail. Serverless also has automatic pause and resume. What serverless can do is it can take a database offline when it is not being used. It automatically pauses it after a period of inactivity, which is called the auto pause delay. And I'll talk about the auto pause delay in a little bit more detail later. But it takes the database offline. And then when you want to start using it again, it will bring that database back online. It will resume it. And I'll talk about automatic pause and resume in a little bit more detail later in the session as well. Serverless is billed per second. And this is important because if you remember, provisioned was billed per hour. So this is really important. You need to think about this when considering your workload, because obviously if you've got a workload that's maybe currently in Azure and uses a high number of vCores on a consistent basis, then that might not be a good fit for serverless because if you're being billed per second and your vCores are consistently high for a long period of time, that's going to cost you more money than if it's on provisioned and you're getting billed per hour. So those types of workloads probably aren't a good fit for serverless. And with serverless, from a feature perspective, there is nothing different to any other Azure SQL database. From a feature perspective, it's exactly the same. You've still got geo-replication, you've still got long-term backup retention, you can still use TDE, you've still got adaptive query processing. From a feature perspective, nothing changes. What that also means is that anything you've previously not been able to do in Azure SQL database, like SQL Server agents and cross-database queries, well, you still haven't got those with serverless either. However, there are workarounds for those. So if you want to replicate SQL Server agent, you can use Elastic Jobs. And if you want to replicate cross-database queries, you can use Azure Functions. Those same workarounds are still available with serverless. And the last thing to mention about serverless, which if you were connected early enough, you might have caught Joey saying, there is nothing mysterious going on in the background where your database is not sat on a server. It's called serverless because Amazon called their equivalent offering serverless as well. So Microsoft just matched up the naming conventions. So I've talked about vCores a lot, but I haven't really talked about memory. So let's talk about that here. So memory is allocated on a per vCore basis. So the ratio is about 3 gig of memory per vCore. So if you set a minimum number of vCores to 3 vCores, you're essentially getting 9 gig of memory. And the max number of vCores to 6 vCores, you're getting 18 gig of memory. And then the auto-scaling will take over then and manage those resources in the background, as I've previously described. An important thing to say about memory is when your workload drops in the background, the memory that it was previously using will be reclaimed. Now, the reason for that is so that Microsoft can pass on those cost savings to you, because that memory that was previously being used by the workload, it no longer needs now. And if it's not using it, why are you paying for it? So Microsoft wants to reclaim that memory back so that it can pass those cost savings on. The positive side of that, it saves you money. The bad thing about that is it can impact on performance. And if you've got a workload that is particularly sensitive to memory changes, then that workload is probably not a good fit for serverless. Use cases. So I've given a couple of examples so far of situations where serverless might not be the best fit, but where would it actually be useful for? Well, these scenarios here. Serverless is designed for intermittent, unpredictable usage with low compute or long periods of inactivity. So there's a couple of things, classic examples that fit into that. Maybe you've got test databases that you only access when somebody requests a change or you need to change some code. The rest of the time it's just sat there idle. Maybe you've got demo databases for sessions like this, and those databases only get used when you run your session. Maybe you've got databases for products that you demo to customers. And again, that database only gets used while you're demoing that product to the customer. Maybe you've got a database that's currently sat in the provision database tier, and you're regularly, either manually via the Azure portal or via some kind of Azure CLI or PowerShell script, you're having to scale up that number of vCores up and down. Well, what you could do in that case is move the database over to serverless, set the minimum number of vCores to the number of vCores that you normally scale down to, and the maximum number of vCores to the number of vCores that you normally scale up to. And then in the background, serverless will take care of the rest of the auto scaling for you. And the last scenario on that slide is maybe you have new databases where the usage pattern is maybe unknown. So you're not quite sure what the usage pattern is going to be. Try it on serverless. See if that works out as a cost-effective solution for you. It's very easy to move databases around between service tiers and compute tiers within Azure. And I'll show you how to do that a little bit later when we come to the demo. Essentially, if you've got databases sat around on servers that are very rarely used, or you've got databases sat in Azure, maybe on the DTU basic tier, and it's using 5 DTUs because it doesn't get used a lot and you're just basically looking to pay the minimal cost, or you've got something on the provision tier that's just been set to minimal resources because it doesn't get used a lot, they're probably prime candidates to move over to serverless. So I've talked about a lot of the features of serverless a lot, but sometimes a picture helps. So this picture is an example of a typical serverless workload. So in this example here, the minimum and maximum number of vCores has been set to 1 and 4, illustrated by the blue line next to the 1 and the yellow line next to the 4. And then during its office hours, if you like, from 8 a.m. in the morning till 10 o'clock at night, it's just regularly being used. And as you can see, the auto-scaling is scaling up the resources in the background. We start off at 1 vCore around 9 o'clock, and it gradually, that orange line you can see going up, which represents the vCores being used, until around 1 o'clock, 2 o'clock in the afternoon, when it hits the maximum of 4 vCores. And that auto-scaling is just going on automatically in the background. And then as the workload drops in the afternoon, the auto-scaling then scales those resources back down. And that memory reclaiming that I talked about before, that's where that would also take place in the afternoon after those resources have been scaling back down. So during this everyday usage period, between 8 a.m. and 10 p.m. in this case, you're being charged for the vCores that you use, which is represented in this diagram by the orange line. And as you can see, the vCores build is represented by the green line. And if you look, it nearly always goes up to exactly the orange line, because you're being charged for what you use, as well as the storage that your database needs. And then at 10 o'clock, the database becomes inactive. You've got this period between 10 p.m. and 11 p.m. where the database is inactive. So what's happened there is the last person in the office has closed down the application's disconnected from the database, and the database is now just sat idle. And this is, in serverless, what is known as the auto pause delay period. And the auto pause delay period is the period that a serverless database needs of inactivity before it will enter a paused state. Now, during the inactive period, you are being billed for the minimum number of vCores and your database storage. Then the database enters a pause state after a period of inactivity. That period of inactivity has to be set to a minimum of an hour, as it has been in this case, but it can actually be set to anything up to 7 days. So then we enter the pause state. At this point, your database is actually offline, and you are only being charged for your database storage and nothing else. And then in this example, at 5 o'clock in the morning, somebody comes back into the office, they load up the application connects to the database, and as soon as Azure sees that connection, it will bring the database back online. So, auto-scaling. I've talked about this a lot so far already. I just want to go into a bit more detail here. As I said, it depends on the minimum and maximum number of vCores that you provision. And in the background, Azure just manages that, or the serverless just manages that auto-scaling for you. You don't have to do anything. The minimum number of vCores you can set is 0.5. The maximum number of vCores you can set is 40. As I mentioned when I was talking about memory, the ratio is 3 gig of memory per vCore. So that's where that maximum amount of memory of 120 gig comes from, 3 times 40. The maximum size that your database can be to go onto serverless is 4 terabytes. So if you have a database that's bigger than 4 terabytes, then unfortunately you're not able to use serverless. Another thing to note about the auto-scaling is that the scaling and compute are disconnected. So what this means is the auto-scaling is completely unaffected by the database size. So it doesn't matter if your database is 10 gig or 3 terabytes. Because the scaling and compute is disconnected, the time to take to scale it up will be exactly the same. The only scenario where you might get a potential delay is if internal load balancing is required within Azure. This is a rare event, and this will happen, for example, if you want to scale up your number of vCores. So let's say, for example, you want to scale up your number of vCores to 10 vCores. And you do that, and it goes off to Azure, and Azure says, actually, I've only got 8 vCores available here. Hang on a minute. It then needs to do some internal load balancing in the background to make those extra 2 vCores available to you. And at the end of that internal load balancing process, it will drop the connections. And I said at the beginning, when I was talking about serverless, there is one scenario where you might get a very small amount of downtime with scaling in serverless. And this is that scenario, because at the very end of the internal load balancing process, it will drop the connections. And when it drops the connections, that's when you get your very small period of downtime. But that, as I said at the beginning, that's a very rare event. So I've talked about this process of your serverless database being paused and going offline and then resuming and coming online again. But what actually goes on under the covers when that happens? Well, typically your serverless database sits in a typical Azure SQL database architecture like this. When it wants to pause your database, it will take a tail log backup of your database. It will detach the MDF and LDF files. Then if it's the only database on the instance, it will actually shut the instance down, and then it will stop billing you for compute. And that pause process can take anywhere between 1 and 10 minutes at the moment. Then when it sees a new database connection and it's paused, the reverse happens. It will start billing you for compute. It will bring the SQL Server instance back online if it's had to take it down when it paused it. It will reattach your MDF and LDF files, and then it will bring the database back online. And that whole process takes about 30 to 45 seconds on average, but can take up to a minute. The other thing to say about the pause resume process is if you have database DMVs that get flushed when a database restarts, then they will get flushed when the database resumes. And that brings me nicely on to auto resume. So auto resume is that 30 to 45 second period that I've just been talking about that a serverless database needs to come back online. It's normally triggered by a login. It can be triggered by a number of events, but it's normally triggered by a login. So that means that if the database is paused and your application connection is the first connection to connect to that database, then it will probably fail because you're trying to connect to a database that potentially may not be available yet to take connections because it needs that 30 to 45 second period to come back online. So as with any Azure SQL database, it's really, really important with serverless databases that you build retry logic into your applications when connecting to a serverless database. And one of the ways you can do that is to set an application timeout to between 30 and 60 seconds. And the last note on that slide is specific to SQL Server Management Studio. If you are using SQL Server Management Studio 18.1 or earlier, and you connect to a paused serverless database, it will bring every single serverless database on that server online, not just the one you're connecting to, which means you'll be getting charged for the minimum number of vCores and the storage for every single database on that server, not just the one you've connected to. So if you're connecting to serverless databases, it's recommended that you upgrade to the latest version of Management Studio. So, auto pause delay. The auto pause delay is that period of inactivity that I talked about. If you think back to the picture that I showed you of my workload, it was that period between 10 and 11 o'clock at night where the database was just sat idle with no connections to it before it became paused. That's the auto pause delay period. It can be set from anywhere between an hour and 7 days. It has to be set to a minimum of 1 hour. And during the auto pause delay period, you're only charged for the minimum number of vCores and the storage that your database is using. The two things that start the clock on that auto pause delay period are when the sessions equal 0 and the CPU usage equals 0. So if you always have a session connected into the database all the time, then your database will never pause. It will always be sat online and you will always be charged for the minimum number of vCores and the storage. You won't get the cost benefits of the database being paused. And that brings me to the fact that the auto pause delay can be disabled. So there may be scenarios where you want to pause the auto pause delay, where you want to disable the auto pause delay. And that's where you maybe have a workload that needs the database to be online immediately. Maybe the workload cannot wait for that 30 to 45 second period that a serverless database needs to come online. In that case, you can still use serverless, but because you can disable the auto pause delay. And that means that your database will always be online. The downside of that is you will always be charged for the minimum number of vCores and your storage. You won't get those cost benefits of the database being paused where you're just charged for storage. So it will work out a little bit more expensive to disable the auto pause delay, but you can still by all means use serverless. There are also a couple of features within Azure that do not support the auto pause feature. So if you have a database that uses one of these features, then it's similar to disabling the auto pause. If you need your replication or long-term backup retention, or your serverless databases, the sync database in SQL Data Sync, or the job database in Elastic Jobs, then you can still use serverless, but those databases will always be online and you'll always be charged for the minimum number of vCores and your database storage. You won't get the cost benefits of the database being paused where you're only charged for storage. The other note on there is about service updates. This is really the only scenario where your database might be online longer than the auto pause delay period. Because if a service update requires the database to be online and your database has, say, been inactive for, say, 50 minutes, when the service update starts, that will essentially stop the clock on the auto pause delay period, do the service update because it needs the database to be online. So it will bring the database back online to do that. And then when the service update finishes, the clock will start again on the auto pause delay period. And that's equally true if your database is paused and a service update needs to bring the database online to complete the update. It will do that automatically behind the scenes. And with that, I shall go to demo. Okay. So this is my demo environment, my Wheelie DBA sandbox in Azure. As you can see, there's 4 databases here. I've got my AdventureWorks database. I've got my AdventureWorks DW database. So the AdventureWorks databases are serverless at the moment and is paused. The Stack Overflow database is also serverless and is also paused. And then we have the AdventureWorks DW database, which is currently on the basic service tier, and the AdventureWorks LT database, which is on the provisioned compute tier in general purpose. So the first thing to call out here is that you can have databases that are on different service tiers and different compute tiers on the same server as I have on my server here. So it doesn't necessarily follow that all of your serverless databases have to be on one server within Azure. So the first thing I'm going to show you is how to create a serverless database via the portal. And we start doing that by clicking Create Database here. As you can see, most of this information is pre-populated already. You've got my resource group name there, and I just need to enter a database name. So I'm going to call this my serverless demo DB. I'm not going to click review and create straight away, and I'll explain why that is in a minute. Then I'm going to go to the networking options and leave those. And then I'm going to go to the additional settings. And the reason I didn't click review and create straight away, because if I'd have done that, it would have enabled advanced data security down here, and it would have brought all of my serverless databases online. And for the purposes of this demo, I don't want that. I'm going to leave the tag options there, and then I'm going to go to the review and create screen. And the other reason, I've missed a very important option. So let me just go back. Here, I wanted to go to configure database because I was creating a provision database. If I carried on with that, we select serverless, and here we can set the maximum and minimum number of vCores. So in this example, I'm going to set my maximum number of vCores to 8. And I'm going to leave the minimum number of vCores at 1. Then we have our options to set the auto pause delay. If you want to disable the auto pause delay, like I've just talked about in the slides, then you can do it by unchecking this tick box here. That will disable the auto pause delay. I'm going to leave that enabled for the purposes of this. Then you set the auto pause delay period. As I said in the slides, this has to be between 1 hour and 7 days. So I'm going to leave that at the default of 1 hour. And I'm then going to change the database size down to 1 gig. And I'm going to click apply. And then I'm going to go through all of the options that I did before. And this brings me to the price screen that I'm more familiar with. This will give you an estimated cost for the database. So mine's only a 1 gig database here, so it's quite small, but the storage cost is going to be about 13 pence a month, and the compute top cost is going to be fractions of a penny per vCore second. So I'm going to create that database, and I'm going to leave that running in the background and come back to that later. Okay. So there is also monitoring available for serverless databases. So that's the next thing I want to show you. You can access the monitoring through the activity log here. I'm using my Stack Overflow database in this case. I'm just going to expand the time span to a month to give us some useful information. Come on, Azure, you can do it. There we go. So here you can see various times when the database has been paused and resumed, taken offline and brought back online. The log keeps a record of all the dates and times that this happened. Also, if the database was unavailable for any reason, it activates a health event with a red X further down here. So that keeps a track of all the events against the database for you. And while I was talking there, I think our serverless demo database completed. And there it is, my serverless demo DB. It's on the serverless compute tier in general purpose. So that's how quickly you can create a serverless database in the Azure portal. So, but what if your database is already in Azure? And what if you want to move it across to the serverless compute tier? How easy is that? Well, let me show you. I've got my AdventureWorks DW database here. It's currently on the basic service tier. But I know that I don't really use this database very often. And it's kind of sat there on the basic tier doing not a lot. And I know from my previous bills that this probably costs me about 15 pence a day at the moment. And I know from tests I've done when I've moved databases over to serverless that if you leave a database on serverless doing nothing, the way I've got this database on basic doing nothing, that cost can go down from 15 pence to about 1 pence. So I want to save some money, so I'm going to move this database over. And to do that, you click on the basic pricing tier here. And this takes you to its current setup. So you can see that it's currently using 5 DTUs and 1 gig of storage. So if I want to move that to serverless, I click on my vCore-based purchasing models over here. That automatically takes me to the general purpose screen. And we have a very familiar screen to us because this was exactly the same screen we had before when we created our serverless database. So again, I'm going to select serverless, I'm going to set my maximum vcores again. I'm going to set it to 4 this time. I'm going to leave all the auto pause delay options at default as I did before. And I'm going to set the database storage to 1 gig. One thing to mention about the auto pause delay period is you'll see here the minutes are actually in 10-minute blocks. And that's because the auto pause process, the process of taking the database offline, can take anywhere between 1 and 10 minutes. So that's why those minutes are in 10-minute blocks there. And I'm then going to click apply. And it's then going to start moving that over in the background. So I've shown you how to create a serverless database in the Azure portal, and I've showed you how you can move a database across from another service tier to serverless. But what if we want to connect to one of our paused databases here? So we've got the Stack Overflow database here. It's currently paused, but we want to connect to it. So let's do that and see what happens. Let's hop over to Management Studio. Another thing to mention about serverless is you can access your serverless databases in exactly the same way that you can any other Azure SQL database through Management Studio or Azure Data Studio. It just, there's no difference in the way you access it. It works exactly the same way, and you can see my serverless demo DB there. So let's try and connect to our Stack Overflow database. So you can see here, I've got the blue spinning circle of death, because what's actually happening in the background is it started billing me for compute again. It's reattaching my NDF and LDF files from my Stack Overflow database, and it's bringing my database back online. What you are seeing here is that 30 to 45 second period, resume period that I talked about, that a serverless database needs to come back online. And that's what it's trying to do here with my connection. And sure enough, I've got an error. It says database Stack Overflow on server Wheelie DBA Sandbox is not available. And that's because I've tried to connect to the database before it was back online again and ready to take connections. So that has produced an error 40613 error. And this is one of the errors that you will need to catch in your retry logic in your applications when you're coding your retry logic to connect to serverless databases. There are also a couple of other error messages you need to capture, and there'll be details about those in a link on my resources slide at the end. What I would say is I've got a bit of a confession to make here. If you're using something like Management Studio and Azure Data Studio and you leave the connection timeouts at the default, this will happen far less. I have to confess, I've changed the connection timeouts in my Management Studio here for the purposes of this demo, so I could show you this error. But normally, if you're using tools like that, you will encounter this error on a far less frequent basis. So if we click OK there and we try the connection again, I don't think I clicked it there the first time, and it just works. We are in to our Stack Overflow database. So how quickly does serverless auto-scale? Let's have a look at that. I've got a little auto-scaling demo here. So the first thing I'm going to do for this demo is clear my procedure cache. And the reason I'm doing that is because the adaptive query processing behind the scenes in Azure actually fixes the second query I'm about to run and makes it run far better than I actually want it to. So I'm going to clear my cache first so that there's no record of that. So I've then got a query here. It's actually two queries. Both queries essentially are querying system objects. They're materializing a table, and then they're doing a nested loop join. And they're two queries that are going to run alongside each other. So I'm just going to run that, and I'm going to leave that running for about a minute. So while that's running, I'm just going to not go to PowerShell. I'm going to hop back to my Azure portal here, and we can see that our AdventureWorks DW database that was previously on the basic service tier has now been moved over to the serverless tier there. So that's how easy it is to move a database from another tier over to serverless. So if you have that scenario that I talked about at the beginning, where maybe you've got a new database where you're not quite sure what the workload's going to be, it's very easy to try it on serverless and see how much it costs. And then if it works out to be too expensive for your workload, then you can move it back over to provisioned if that's more effective. And it's literally, you know, it's that simple. You can move it to provisioned in exactly the same way. So back to my query in Management Studio. Okay, so what I'm going to do now is I'm going to run this DMV, sysdm db resource stats. And what this is going to tell me is, it's going to tell me how much CPU my query was actually using while it was executing. It'd be a good idea if I stopped it first. There we go. So it's going to tell me how much CPU that query was using while it was executing. So let's have a look. So we can see here at 9:39, because this server time is in UTC, at 9:39, my server was using 0% CPU of its 8 vCores. And then by 9:40, dead on the minute, it was using almost 100% of 8 vCores. So in a maximum of 30 seconds, it's gone from nothing to using almost 100% of 8 vCores. So that's how quickly in the background, the auto-scaling can scale up the resources. And I say a maximum of 30 seconds because this DMV collects data every 15 seconds. So you are restricted by the data collection time of the DMV. It probably happened in something like 25 seconds. So I've shown you the auto-scaling. I've shown you how to create a database within the Azure portal, and move databases around in the Azure portal, but you don't really want to be doing everything in the Azure portal. Some people like to script things, right? So how do you spin up a serverless database using PowerShell? Well, let's have a look. So I've already connected into my Azure account here. And first thing I've got in my script is a return statement. And that's to make sure that I don't press F5 and run all of the demos, because I would do something like that. And that was a tip I picked up in one of Rob Sewell's PowerShell sessions. So thanks for that tip, Rob. Right, so the first script we're going to run here is going to create a serverless database. And what I'm going to do, because this takes a while to run, I'm going to run it and then I'm going to explain it. Okay, so that's going to run the background. So what we're doing is we're feeding in some parameters, my resource group, SQL database RG. I've given it a name, serverless posh test DB. I've set the minimum number of vCores to 0.5 and the maximum number of vCores to 1. I've set my database size to 2 gig, and I've set my auto pause delay to 60. I'm then using my minimum size in bytes variable to convert my 2 gigs to bytes, because Azure likes everything in bytes. I'm then using the getAZ resource CMDlet to get my server name from my resource ID. You could easily just type the server name in there. I've just tried to do something fancy. And then I'm using the new AZ SQL database CMDlet to create my serverless database by populating it with the parameters that I've defined up above. And I've also hard-coded some values, because at the moment, serverless is only available on Gen 5 hardware, and it's only available on the general purpose service tier. So those values are hard-coded in there. And as you can see, while I've been talking, it's now created my serverless database. It's set the minimum number of vCores to 0.5. If you're using PowerShell, the minimum number of vCores is called the minimum capacity. It's just an alias for the minimum number of vCores. They mean the same thing. And it's set the capacity, the maximum number of vCores, to 1. And it's set my auto pause delay to 60. It's also got the read replica account here, but you don't need to worry about that because that only applies to hyperscale. Okay, and that's it. Our database has been created. And if we hop back over to the Azure portal here, we can actually see that there. There it is. It's on serverless. Click into it there. It's on serverless. And that's how quickly it is to spin a database up via PowerShell. So what else can we do in PowerShell? Well, we can actually change some parameters. So we can change the auto pause delay, and we can change the minimum and maximum number of vCores if we want to. So let's have a look at that. So again, I'm going to run this and describe it later. Okay, so what we're doing here is, at the moment, you'll have seen originally that my database was set, the auto pause delay was set to 60 minutes. So what we're doing here is we're changing that auto pause delay to 75 minutes. And I've set the same parameters that I've set before. That's the only difference. I'm getting my server name in the same way. This time I'm using the set AZ SQL database CMDlet to change that auto pause delay in minutes. But we have an error. And this is an intentional error. It says essentially that the auto pause delay value of 75 is not supported. And that actually is absolutely true. Because if you remember, when we were creating my serverless demo DB, I said that the auto pause delay minutes was in 10-minute blocks, as you can see there. So the reason the value of 75 isn't supported in the auto pause delay is you can't divide 75 by 10. It has to be in a 10-minute block. And that's why you're getting that error in PowerShell. Now, obviously, if you try and reconfigure the auto pause delay via the portal, you won't get this issue because it won't allow you to enter an invalid value. But if you do that via PowerShell or via the Azure CLI, then that might happen. And if you get that error, that's essentially what it means. So the takeaway is always ensure that your auto pause delay essentially can be divided by 10. So 60, 70, 80, 90, all valid values. 75 is not. So what if we want to change the maximum number of vCores? Let's try that now. So currently, our maximum number of vCores is set to 1. And I'm going to use this script down here to change that to 3. Again, I'm using the set AZ SQL database CMDlet. And this script is exactly the same as the one above. The only differences are that I've changed the auto pause delay back to 60, and I've changed the maximum vCores to 3. And we're just going to run that. The other thing to say about these CMDlets that I'm using as well, the set AZ SQL database, and also the new AZ SQL database, they can be used with provisioned as well. And we have another error. Again, this is an intentional error. Slightly different error message this time. It says the tier general purpose does not support the SKU SQLDB GP underscore 5 underscore gen underscore 5 underscore 3. What on earth does that mean? Or at least that's what I thought when I first saw this error, because this particular demo kind of came about while I was prepping for this session, and I actually hit these errors myself when I was playing around with PowerShell. So my initial thought when I first saw this error is, what on earth does this mean? So although serverless is only supported on Gen 5 hardware, it's not supported on every service objective of Gen 5. So it means that you can only set the minimum and maximum number of vCores. You may hit this issue with the minimum number of vCores as well, to certain values. And all of that is documented by Microsoft, and there's a link to that documentation at the end. But if you're ever in doubt, just check the Azure portal. The Azure portal doesn't allow you to enter invalid values. So all the valid values for the maximum number of vCores are here: 2, 4, 8, 10, 12, 14, and so on. But 3 isn't a valid value for the maximum number of vCores because it's not there in the portal. And that's essentially what this error message is telling me. So, third time lucky with this demo. This time we're going to set the maximum number of vCores to 4 and the auto pause delay to 70. Again, the script is exactly the same. All that I've changed about this script is the parameters at the top. It's exactly the same as the previous 2 scripts that I've run. Come on, Azure, you can do it. It's at moments like this I probably should pay for faster internet, maybe, I don't know. There we go. So, there we go. It's set our maximum number of vCores to 4, which was exactly what we wanted, and it set our auto pause delay to 70. Right there. And we've actually got the get AZ SQL database command, which you can actually use to look at this information in a bit more of a friendly way. So if I run that, and this will run a bit quicker, hopefully, that will go off and return some information about my database. So you've got the resource group name, which you've seen a few times. You've got my server name, which we know all about. My database, my serverless posh test DB, the fact it's in the UK West data center, its general purpose, it's on 5.4 because I've changed the parameters, and there's our capacity and our auto pause delay in minutes that we've changed in the previous demo. I do have one last demo, which I'm not going to run because I'm conscious of time. That shows you how to move a database from another service tier. I think it's provisioned actually over to serverless, but the scripts will be available afterwards, so you can have a go at that one yourself. So I'm going to jump back to the slides now. So I've shown you what serverless can do. I've told you it can save you money potentially. Now I've got to tell you some of the limitations, unfortunately. This is the sad face slide. The first of them you've already seen. You've seen that if a database is paused and your connection is the first connection, then it might fail. And that's exactly what happened in the demo when I tried to connect to my Stack Overflow database through Management Studio. As I also said during the demo, it's only supported on general purpose at the moment. It's not supported on hyperscale, it's not supported on business critical, and it's not available on managed instance. I mentioned in the demo that it's only supported on Gen 5 hardware. It also doesn't work in national clouds. So if your database is on a national cloud, you won't be able to use serverless. Also be aware that the price of serverless can vary by region. So just double check the pricing before you use serverless. And the last note on that slide is about Azure Hybrid Benefit. Azure Hybrid Benefit discounts do not apply to serverless. So for those who don't know what Azure Hybrid Benefit is, if you have SQL Server licenses on premises with software assurance and you want to move them into Azure, Microsoft will give you a discount on those prices, on their Azure pricing for moving those licenses into Azure, but those discounts don't apply to serverless. So what's coming with serverless? As I briefly mentioned, hyperscale support is on the way, but it's not here yet, but hyperscale support is on the roadmap. Microsoft are also looking at doing pause and resume improvements. So they're looking at improving that 1 to 10 minutes it takes to take the database offline and that 30 to 45 seconds it takes to bring the database back online again. They're looking at making that faster. They're also looking at extending the hardware support beyond Gen 5, specifically to the M series and the FSV2 series. Microsoft are also looking at building in the retry logic within Azure, and that's so the emphasis isn't on developers to build retry logic into their applications to handle those intermittent connectivity issues that you can get with all Azure SQL databases, not just serverless. But Microsoft are looking at maybe building that retry logic in on the Azure side of things so that the developer doesn't have to do it. And they're also looking at putting support in place for availability zones at some point in the future as well. So that's serverless. As I mentioned, it's best suited to intermittent workloads that have long periods of inactivity. So that particularly lends itself to test, dev, and demo databases that aren't used that often. As I mentioned, it's only supported on general purpose and only supported on Gen 5 hardware at present. As with all Azure SQL databases, connection failures will happen. So it's really, really important you implement retry logic into your applications to handle those connection failures. So last but not least, the best thing about serverless is that it can save you money. Now, your organization always loves you if you can save them money, right? But at the moment where organizations are struggling and they're looking at ways of cutting costs, serverless could be potentially one of those ways that they could cut costs. So if you can suggest this to them and possibly move a few databases over to it and they can see those cost savings in action, they will probably love you even more. And lastly, my resources slides. So the first link will give you more information about the compute tier limits. So that will tell you which service objectives support serverless and how much memory and CPU you get per vCore as well. If you want more information about pricing for serverless, that's the second link. There's a couple of examples of how to implement retry logic into applications, the last two links to that slide. If you want to download the Stack Overflow database that I've used for this demo, you can do that on Brent Ozar's website. Thanks to Stack Overflow and Brent for making that available. If you want more information about the connectivity messages that you can get when connections to Azure fail, that's the second link on that slide. I showed you one error message when I connected from Management Studio, but there are a couple of others that you need to catch, and information about those errors are on that second link. And finally, if you want more information about serverless generally, that's the bottom link on that slide there. And that's pretty much all I have, so I'll throw it open to questions.
Nice one, Shaun. Thank you very much, mate. That was a fantastic session. That was really, really awesome. And it gave me some, some thoughts about what I might want to do, say, for some of my clients who have, dev systems and what have you. So, yeah, no, that's great. Alrighty. While I go through the questions, just a reminder to everyone, I've just posted the eval form in the chat window there. Alrighty, I think I know the answer because this question came in before you covered it, and then you covered it, but I'll ask the question anyway.
If you want to make a new speaker very happy, ask them a question that's covered later in their slides.
Can you manually pause, and is there a PowerShell command to achieve that?
No, you can't manually pause. So I think in Azure Synapse you have got the ability to pause, and I think that's probably what that question is referring to. You can't do that with serverless. A serverless database needs that 1 hour period of inactivity. Well, a minimum of 1 hour of inactivity before it will become paused. You can't literally just press the pause button and it will stop.